Okay, we're going to look at reasonable graphs, trying to figure out what the lines mean, which way we're going, and what's happening. First off on your paper, let's go back here and look. I've got time versus distance. Time is going to go down here on the x-axis. It is my independent variable. Distance is my dependent. Because as the time goes on, that depends what happens to my distance. Now, when I'm looking at this, first off, what kind of correlation is this from yesterday? It is a positive correlation. How do you know it's positive? Yes, from left to right, it's increasing, it's going up. Now, this line is a straight line. It means that I'm going up at a constant rate of speed. So let me go over here and do this. It might be easier to do this. All right, here we go. We've got a positive association or correlation. Right here, this line is going up at a constant rate. As time is increasing, distance is increasing. I talked about positive associations, that if both things are going the same direction, that they are positive. So if they're both going up, it's going to be a positive association. And I know it seems weird, but if they're both decreasing, it's still a positive association. Think of it again like multiplying. A negative times a negative is a positive. Okay, we'll have to look and use more examples to show how that happens. This line, though, is showing that you are walking away from something. This is saying that I'm starting at 3 feet. Say I'm 3 feet, maybe I'm 3 feet away from my desk. And I'm walking at a constant rate away from my desk. Okay, the next one, we're talking about a negative association. When it's negative, the line is going down from left to right. It's decreasing. And that happens because when time is increasing, distance is decreasing. We talked about the fact that if they're going in different directions, like if one is positive, one's negative, it's a negative association. And again, I told you to think about multiplying, because a positive times a negative is a negative. This is like you're walking towards something. So as I'm going, I'm walking back towards my desk. Maybe I'm 9 feet away. That's what my starting point is. I'm 9 feet away and I'm walking back towards my desk. Now I'm walking at a constant rate, and the reason why I know that is because the line is straight. You may want to make a note of that. The line is a straight line. That's what's making it constant. On the next slide, right here, we've got a line that is increasing and going up, and then it flatlines. This is like saying I am 2 feet away from my desk, and I'm walking. Now I'm about to say slowly, and we're going to talk about that in a minute. I'm walking slowly away from my desk, and then I stop and I stand at a student's desk. I know that I am stopped because it is a flat line. What's causing the flat line is because the time is increasing. Right here, I'm talking about this flat line. The time is increasing, but the distance stays the same. I'm not going anywhere. Now, I said that I'm walking slowly. How can you tell between walking slowly and walking quickly? If you're walking quickly, the lines are much what? More steep. The steeper the line, steeper means more vertical. So that is walking faster than that. This line is flatter. This is slower. This line is steeper. That's faster. So an example, I could say that Miss Crawford is 2 feet away from her desk. She walks over to JoJo's desk and stands there and helps JoJo. And I stood there and helped JoJo for 4, let's see if I start at 4 seconds. 1, 2, 3, 4, 5, looks like 6 seconds, except there's an arrow, it keeps going on. But the time that's elapsing is 6 seconds. It took me 1, 2, 3, 4 seconds to get to his desk. That's what those tick marks mean. So I'm walking at a constant rate for 4 seconds. Then I stand in the same spot. On the next slide, right here, as I look at this, right now I'm going up, then I'm walking away, then I'm walking back towards something. So this is away and back towards something. That is why I say that right here at this point I am changing directions. Now let's look at this graph. On this graph right now, on the piece of paper that you have here in class, up there in that box, it says sketch graph A. So I need you to sketch the line, and I need you to label the numbers. Now I'll give you a second to do that. If you're watching the video, then just pause the video. Okay, we have these answer choices down here at the bottom. And when I look at this graph, which one of these choices down here would work for 1, for starting point 1? Aye, chalupa is what I just say. Starting point, didn't mean to. All right. The first one right there is starting point. So at blank 1, you should write down starting point. On 2, what is happening here in this graph? I'm walking at a constant rate. Compared to these other lines, though, am I walking fast or slow? This is going to be walking at a slow, constant rate. Now, wait a minute. One thing I want to add to it is that you're walking away. I'm walking away from my starting point. And as I'm walking away, what happens when I get up here to 3? I stop. But stop isn't down here. I just pause. Same thing, though. So I'm walking, and actually right here at this corner, I'm slowing down. See, right here at this corner, I would be slowing down. They don't have that. You don't just stop instantaneously like you get in a wreck, like poof, stop. Okay, you're walking, and then you slow down and you pause. Now, what's happening in 4? Am I walking slow or fast? How do you know you're walking fast? It's steeper. You are walking at a, wait before you write, you're walking at a faster constant rate. But from my starting point, am I walking away or towards it? My starting point's here. Away, I'm going farther away. This is my distance. So again, I'm walking away. At a faster constant rate. It is constant because it is a straight line. What's happening at 5? There's my answer choices. What's happening? I'm changing directions because I was walking away. Now at 5, I'm changing directions. And now I'm walking back. I'm not even walking back. What am I really doing? That line's really steep. I'd say more like I'm running back. Right? That's a really fast rate. Because it's very steep. Whoa, that was slow. Let me grab the right one. Faster. You're running back. That line is steep. It's almost, and for some people you're saying, well, what is steep? Steep means more vertical. The more vertical your line is, the faster you're going. If you're going more horizontal, horizontal is stopped. So if it's only at a little bit of an angle, that means you're going slower. Okay, let's look at the next one. There's the next one. Sketch graph B. Pause it if you need to. Okay, looking at graph B, here are some of my answer choices. Now, this is why some of them aren't going to fit totally. But I do know what number 1 needs to be. What is number 1? Starting point. We're going to start there. Now, my problem is with number 2, I can't put slower constant rate or faster constant rate. Why? It is going faster, but is it a constant rate? What's happening? No, look, this thing you're going slow and then you're speeding up. That's a curve. Okay? The constant rate has to be a flat line. I mean a straight line. Okay? When it's curved like this means that let's see, I'm walking away and increasing in speed. Because I'm speeding up. Now my next problem is the fact out of these answer choices on part 3, I'm not changing directions. What am I doing in 4? I paused. On 4, I just paused. So if I'm increasing in speed, going faster, what do I have to do before I pause? Slow down. Slow down. So in part 3, you're actually, right here in 3, it needs to say slowing down. Okay, so we're increasing in speed, walking away, we slow down, and we pause. What are we doing in 6? Are we going really fast? We're going at a slow, constant rate. Well, before I can go at a slow, constant rate, I have to speed up. It's not changing directions because I'm still walking away. I've yet to turn around and come back. Okay? Have those written down so I can go to the next one. Now we're going to go to graph C. Go ahead and sketch graph C on your paper. And then we're going to look and see which one of these works and where, and if we need to make some adjustments. Looking at my tabs down here, what's number 1? Starting point. Now, part 2. It looks like it's a constant rate. For the most part up here, where it starts changing is 3. So right here at 2, we are walking away. Now, are we walking away fast or slow? Looks fast. It looks pretty steep. So I would say we're walking away at a faster constant rate. Now, what's happening at 3? Yeah, I'm walking away, and so at 3, I'm changing directions because I'm going back the other way. In 4, am I going fast or slow? I am going slow. It's not as, look, this line, the first line was really steep. 4 is flatter. So this is a slower constant rate. I'm walking back. Now, what's happening in 5? I am changing directions. So instead of walking back, where do I go now? I go back away, and it's going to be a faster rate because it is a steeper line. Make sure you have those down for your graph. Now, if I had to, well, one of the things you're going to have to do is tell a story that goes with it. So, for example, if I went back to this one right here, graph A, I could start with a story on this one saying that Crawl Mama leaves her house and is driving to school out of her neighborhood. She stops and pauses and waits at the stop sign. When the traffic is gone, she speeds up and keeps going towards school. All of a sudden, she realizes, oops, she left her phone at the house. So she turns around real fast, drives real quick, speeding probably, and goes to her house to get the phone. She has to speed because she knows she's late now for school. Then she comes back to the house to get her phone. Okay? Let's see. What story could I tell here? Joe Bob gets handed off the football. And he runs with the football, and he's running down the field. All of a sudden, he sees people coming at him to tackle him. So he turns back. He's kind of going a little bit slower, turning back the other way. Then he sees people coming at him this way from the other direction. So he takes off and runs for a touchdown and sprints. Okay, let's write graph D down. I know it's a lot. On your paper, I'm going to explain how all the numbers, where they all come from. They're kind of typed in there weird. So right now, take a minute and let's sketch this. Okay, on this one, it has a lot of things going on. In the very beginning, what's always number one? Starting point. Okay. Number two, I'm walking away. Am I walking away fast or slow? This would be slow because it's not very steep. It's not very vertical. It's closer to this x-axis than it is to the y, meaning that it's kind of flat. So this is walking away at a slower rate. At 3, what do? Change direction. And at 4, am I walking fast or slow? Look how vertical it is. That is a fast rate. I'm going to draw a line here. So number 4 should be the fast constant rate. Now at 5, I would not say that 5 is changing directions. Well, but when we're going fast, before we're stopped, we have to slow down. Because at 6 is when we pause and we stop. And then at 7, that's when we've got to go and speed back up. So this is going to be speed up. Eight, when we go through here to 8, we are walking at a slower constant rate. Then because at 10, what's happening at 10? She stopped or she's paused. So when you're walking and before you pause, you have to do what? Slow down. Now, if I wanted to make up a story that went with this, I could use a story like this. Kyla comes walking down the stairs. Kyla starts walking out of her bedroom. And she's walking out, and all of a sudden, she thinks there's an intruder in the house. So she changes direction and sprints to her room, and she hides in her closet until she realizes she hears her brother's voice and that he was just playing a joke on her. And so then she gets out and walks back towards Jacob and meets him in the front foyer. And then the rest of this graph doesn't say anything. It just says that Kyla would probably beat him up. Okay? That's just how it works in my household. So there'd be lots of different stories, but that's just an example of what you could write. So if you flip your paper over now, it says in general, describe the placement of each card. How did you decide where they went? Well, the starting point was always at the beginning. A pause was a horizontal, flat line that looked like this. Well, maybe not that, maybe a little flatter. There we go. When you were walking slower, that was a flatter line, or you could write less steep, either increasing or decreasing. Now, if you were walking faster, that is going to be a steep line, either increasing or decreasing. Now, how could you tell when you were slowing down? I know that when we were changing directions, it was at a point. But when we were slowing down, we were going fast, and then we kind of curved and slowed down. When we were speeding up, well, let's see. Let me see if I have a better way of drawing it. So, slowing down. I'm going fast. Yeah, and then I'd have to kind of stop going as steep. So it'd kind of curve downward. It looks like a hill a little bit. If I was speeding up, I would be going slow and then gradually increasing. It looks like a ramp, or you could say curves up. I guess it could curve down. Could it? Slow. I'm trying to think. Slow, and then, yeah, it could curve down. If it was going slow and then it speeds up like that. Okay. Okay. Let's look at these. And like number 1 says, you're going to start 2 feet away and walk slowly. We're going to label our x-axis with time and our y-axis with distance. You can make it the time, you could make it seconds, minutes, it doesn't matter what it is in this case. In this problem it says feet, so my distance will be feet. Now, it says that you start 2 feet away. So that means that you're going to go on the y-axis, you're going to go up to 2 and put a dot. You're starting 2 feet away. Then it says you walk away slowly. What type of line is that? A steep or a flatter line? It's not totally flat like this, because that means they are not going anywhere. But it would have to be increasing just a little bit. On number 2, I'm still going to write time in seconds. And it says feet down here, so my distance will still be in feet. Now, it says start 10 feet away. So I'm going to go up here and start at 10. And it says to walk towards something slowly. So if I'm walking towards something, I'm going back down. And if I'm going slowly, it's going to be a flatter line. It's not totally flat because that means they're not going anywhere. It's got to be either going, if we're going back towards something, it's got to be going down a little bit. Now, flip your paper over. Let's look at number 7. Okay, so on these, what we're going to do, really, try it again. There we go. What we're going to do is you're going to try and describe what's happening. So we're going to start 1, 2, 3, 4, 5, 6, 7. We're going to start 7 feet away. What happens now? Is she going somewhere or staying, or what is she doing? She is paused for how long? 2 lines, or I'm going to make it seconds. So she's 7 feet away and pauses for 2 seconds. Now what does she do? Does she walk away or towards something? She goes towards something. Fast or slow? I'd say kind of quickly. It looks steep. In how many seconds is that? You're starting here. That's important to know what the lines are going by. Like it takes 1, 2, 3, 4, 5. In 5 seconds. Then she changes direction. How do I know she changes direction? What's happening to my line? It's going back up. She changes direction and walks away. So on these on the back side, you're going to describe what's happening with the graph. Everybody's story will be a little bit different, depending on if you put words with it or not. Or, I mean, the numbers are still going to be the same, like how long, where they started from, if they walk quickly, slowly, and stuff like that.